as always, read the why. And in Model 1, there's a couple different experiments here. So let's show you how this sets up. Experiment A is just this top part, and it says what we're going to do is add more gas, and then kind of look what happens to the volume, the pressure outside, external, inside, and the temperature. Just see what happens. Each of these represents a gas molecule, and in this experiment, we're adding more gas into a non-flexible container. In experiment B, says we're heating the gas. So notice 1, 2, 3, 4. There's only 4 particles in each one, but this time we heat it and see how that affects the different variables down there. I guess I gave you number 1, so if you missed it, you can rewind a little. But it's also up there. If you read in the note part, you'll find the answer to number 1. Number 2, name 2 materials that could be made in Model 1 that would be considered non-flexible. And if you don't know what that means, it just means it won't get bigger or smaller. So like a balloon would not be a good answer because it's flexible, it could get bigger or smaller. So what 2 kinds of things could they put the gas in that would not get bigger or smaller? In Model 1, number 3, the length of the arrows represents the average kinetic, remember that means moving, energy of the molecules in this sample. Which variable, P for pressure internal, V for volume, T for temperature, or N for number of molecules, is most closely related to the length of the arrows? In other words, what did we change of those 4 things that made the molecules move faster, the arrows get bigger? Complete this table. Remember, the independent variable is the thing that, if you're doing the experiment, that you change. Which thing would you change? The dependent variable is what you're measuring or counting, and control is something that's kept the same. Remember, experiment A is on the top, experiment B is on the bottom. This green box, as always, read here. And name 2 factors related to molecules moving that influence the pressure of a gas. You could possibly get it from Model 1 at the top, or maybe from the reading, or what you know already from our notes. 6 and 7 say provide a molecular level explanation for the increase in pressure in experiment A, and then 7B. So in other words, what's happening to those little gas molecules? Are they moving faster? Are they getting more of them? Are they moving slower? Are we getting less of them? That sort of thing. Number 8 says, what would happen to the volume and internal pressure in experiment A if we used a flexible container? So something that could expand or get smaller. What do you think would happen? Number 9 says the same thing, but for experiment B. 8 and 9 are hard. We went over them in class, so try your best. Just don't leave them blank. And 10 and 11, again, same question, except 10 is for experiment A and 11 is for experiment B. Is the relationship between the variables being tested directly proportional or inversely? In other words, do both variables go up or down together? That's a direct proportion. Or does one go up and the other go down? That would be inverse. Well, this is weird. Sorry, it just bothers me that it's... Oh, whatever, I can fix that later. Model 2, we have 3 more experiments. And this time, they're in flexible containers. Experiment C is adding more gas, D is heating the gas, and E is reducing the external pressure on the gas. Notice this the flexible container looks like a balloon, so it can get bigger and smaller. And only looking at Model 2, what kind of materials could this be made of? I gave you 1. Try to think of another, but it's okay if you only get the 1. And what's always true for the external internal pressures? So look at them in every picture and tell me if they both go up, go down, or they always stay the same. Just like with Model 1, Model 2, for each of those experiments, you're going to tell me what's the thing I changed, what's the thing we're measuring, and what's something kept the same. Just like the previous Model 1, in this new picture, Model 2, you're going to tell me at the molecular level, the little molecules, the gas molecules, what's happening to increase the volume in the different experiments. 17, 18, and 19 says how would it be different if we used non-flexible containers? And what's similar between like Model 1A and Model C in Model 2, Model B and Model D of Model 1 and 2. Finally, number 20 here says, here's 3 samples of identical gas molecules. They all have the same internal pressure, rank the samples from lowest temperature to highest temperature here. So you're going to put like ABC, CBA, whatever. And then also from lowest average kinetic energy to highest. Once you do that, you are good.